It's not like the old days when everything was simple. There's a video at the end that we put together for the Today Show, which was supposed to air in part today, but got derailed because of the very unfortunate events in Oklahoma, the tornado. So I'd like to try and, my goal is to be on time today. I realize I never achieved that goal, so the best goals in life are simple ones, and I fail a lot. So that's the goal. So then we can see the video, which is fun. We took it catching wolves using a GoPro camera on top of our helmets. So it will be exciting stuff. So my purpose of this talk every year is to always update you on what's going on with wolves, to better prepare you for dealing with visitors and public outreach and education. So what will help me with that, and it will help me decide on how fast I can go, is how many of you are new. So, okay, a minority. So I will maybe go faster through some parts of this. And the slide I threw in that partly caused me to be late, I didn't need to throw in, because most of you are old timers. So this is just kind of what we do right up front. You know, the Wolf Project is kind of split, unlike many other programs, between, I guess you could call it research and management. And that's an artifact of how we got started. So, you know, there were no wolves here, we brought them back. And every wolf was radio collared to start, and this was just too ridiculous of an opportunity to not get as much out of it as you could. You know, life is oftentimes not about what we intend to do, but what we, you know, seize the moment, kind of take advantage kind of stuff. So with every wolf radio collared, we were able to address some things that had not been studied in depth before about wolves. So we have kept that trajectory started by the uniqueness of the reproduction, and that has become even more important as the controversy over wolves has increased. We're almost at 20 years, and I thought it would have lessened, and it's increased. And so this in-depth research has been a good problem solver. Sometimes it creates other problems, but I won't get into that right now. And then we have the typical list of what land managers do. We're not just pure researchers in that, unlike university-driven park research, and you know, no one's ever responsible for life, but we're responsible for the wolves when they do something bad, or people do something bad to them. We're a park, we manage, we step in. So this is the other list of things that we do. And in the interest of time, and I've been talking long enough, you've read those things. So I'm not going to read them to you. And so context is very important. There's a lot of things in life I don't understand because I don't know the background on the issue. I don't know the history. This is a brief history of wolves in Yellowstone. World's first national park. Ken Burns said it best, America's best idea. We should all be very proud of that. But we're not proud of that the original intent of the park was to preserve some animals and get rid of others. Good animal, bad animal idea. And wolves are bad, other predators, cougars, coyotes, lynx, bobcat. Bears, as Carrie Gunther told you, had a different story. Personalities also matter in life. And so the early administrators liked bears. I'm sure Carrie went over that, and that's what kept bears from being eradicated. Wolves were not that lucky. They went out by 1926. So we had a wolfless period, and then due to a change in human attitudes and policy change, Endangered Species Act 1973, wolves were listed in 1974. We reintroduced wolves from Alberta, Canada, northwest Montana, and I'll tell you why this is the end of phase 1 when you see the population chart. But key to this is that some, I underlined 3 times, not all, of people's attitudes changed. Formerly, nobody liked wolves. And the policy for centuries was eradication. Plain and simple. They are contrary to civilization. They compete with us. They kill livestock. They occasionally kill people. Kill them off. And so attitudes started changing mid-20th century. It takes decades to change anybody's mind. And it took until the 70s and 80s till this idea caught hold. And now wolves are a very, very polarizing issue. You either really like them or you don't. Very little in the middle. I try and be in the middle, and it's a very lonely place to be. But this all came about due to a change in human attitudes. Laws then followed. So that's what's key. Some people, not all people, became more tolerant of having wolves around. I won't get into the demographics of that because that's debated and argued about and upsets some people versus others. So this is probably the single most famous photo taken. This is wolf number 1 being brought on the Crystal Creek bench. Penn, January 1995. Very proud of the fact that the interpretation division is working on a new set of hard signs to put out in Lamar Valley, and this picture will be on one of those hard signs. And that job that you guys are doing is an excellent job. And this picture will be there. So big history. It helps me to think, Yellowstone is such an old park, the boundaries were set up because the geysers were cool and they just threw boundaries around them. They didn't really think about wildlife, they didn't really think about ecosystems. I mean, arguably now, we still don't think about ecosystems. But, so the boundaries are imperfect and they capture several different systems in the park. But if we can simplify that to 2 main systems, it's the northern range, which only 65% is in the park. And this is defined largely by where the northern Yellowstone elk herd, which lives predominantly throughout the park, all the park, even up here in Gallup Forest, we know this because we have 73 of them radio-collared right now. And historically, they've had marking studies done, where they winter. And then 35% of this is outside the park, some of which is private land. This has been a heavily studied area for over 100 years, primarily centering on elk and bison, not so much the carnivores, but this is lower elevation, different habitat type, different vegetation, fewer thermal features, less snow than all the rest of this. And there are different systems within this, Mass and Fire, Hope Pelican Valley, Beckler, Southeast Corner Thoroughfare, but I'm not going to divide it up like that, but broadly, there's 2 big ecosystems in Yellowstone, the interior and the northern range, and wolves and ungulates, their primary prey, respond to that. So in terms of thinking about this, it's very good to be aware of that dichotomy, because what the animals do. So here is the end of what I'm calling the first era. End of phase 1, remember back at my history slide? I'm calling this the end of phase 1. Why am I calling that? Just kind of looking at the data. Scientists do this all the time. No statistical analyses, but we went through a boom, kind of bust, and then a boom, and now it's gone down and it's flattened out. So we've gone through this early colonization / settlement period, and now something else is happening. So this is kind of a weird time because the system was perturbed. There were no wolves for 70 years. Wolves came back. It took a while for that to calm down, to stabilize. So this is the period we're in now. The light color here is the interior. The dark is the northern range. And please note that up until about the end of phase 1, the northern range, only 10% of the entire park's area. The park is roughly 9,000 kilometers squared, and the northern range is roughly 1,000 kilometers squared. So in a little over 10% of the park's area, you had more than half the wolves. So hark back to the slide I just showed. 2 systems, very different. Animals respond to them very differently. 7 elk herds in Yellowstone. The biggest one is the northern Yellowstone elk herd on the northern range. So please keep that in mind throughout. But there's been a decline, and I would call stabilization in numbers in both areas. You can see that bar graph. End of phase 1. We're into a period where different things are happening. And this is another way of looking at the same data presented differently. And all of you who think about this and write about this, how is it best to present the data? Well, sometimes it works differently for different audiences. So this is the same graph, and it's a bar graph, but it shows the effect of canine distemper virus. 3 disease outbreaks, 99, 05, 08, and what it did to the population. It declined. Big disease. And it primarily caused the northern population to decline because of a higher wolf density, and density affects disease transmission. But importantly, there's been, each time it hit, there was a recovery in wolf numbers, not the third time. Again, the thinking behind, and some of you may want to challenge this, again, that's how we all advance, by challenging others' thinking, is that this isn't the end of phase 1, that it's still in some kind of settlement colonization stage. We've got another disease that we're working on now, midstream. Emily Omberg, Penn State University in Princeton, she's got a shared advisorship, but it's mange, and this is what mange does, and I'm not going to discuss details of mange right now, but we're trying to address mange, and where mange doesn't hit like distemper. Distemper comes and goes, mange kind of hangs on. It's always around. Now it does appear to wax and wane a little bit, but you know, bad years, good years, but it's kind of always present. And we're working on what affects that. And interestingly, some early results from Emily's work show that bigger packs don't get mange quite as severely as smaller packs. And that's because not everybody in the pack gets it. So in a big pack, you're going to have pack members that are in better shape and can possibly help provide food and take care of some of the animals that get it worse. There are exceptions. The Druid Peak pack, all of them pretty much got it, and they went extinct. So we're trying to work through those differences, but in general, there is a pack size effect, which is a very interesting discovery in Emily's work. So here is the juxtaposition of packs right now. Our year-end count, I think I have a slide, maybe I didn't because it's too detailed. The wolves, we're kind of counting them all year, but best in the winter, early and late. And our official count required by law is the early winter count. And so this year was 83 wolves in 10 packs, and 6 of those are breeding pairs. And that's about what it was in the late 90s. I can flip back to that bar graph if you want. The peak population was 2003 with 174 wolves. So this is about half the numbers we had after the post-reintroduction boom. And so that's probably a natural outcome, is that wolves really responded to abundant prey. The prey has declined, the wolves have declined, and wolf and prey are now in more equilibrium. I could go through all these. This pack is not collared. It hasn't been collared for some years, but we were doing a swan flight last October, and we saw at least 10 to 12 of them. And several of those were pups, so we know they are there. We don't know how they overwintered. Snake River ranges mostly out of the park, but and we only had 6 locations on them last year. But Wyoming thought they were more a park pack than an out-of-the-park pack. Delta pack has much greater range outside the park, but we don't include the locations of other agencies. 8 Mile is a boundary pack. Blacktail is down to just 2, and it looks like they didn't reproduce. Agate is gone. Junction Butte has got 2 different litters. They're about 9 or 10 all counted. Lamar Canyon has split up. There's a group of them in Sunlight Basin, Wyoming, and there's 3 in the park, in Lamar Valley, on a den. Molly's pack is down to 3 wolves. We think they're denning. That and Delta are the 2 oldest packs left in the park. They both established. Molly's 1995, same with Delta, and they are the long. So since the first year, they're the 2 longest running packs. That's the record. Average pack life's about 10, 12 years. So they're approaching 19 years. So that's pretty good. So there must be something about getting going early, picking a good territory early, and then some of those packs have had stable leadership, low overturn of leader, alpha bulls. So we think all three of those factors lead to their stability. Canyon is denning in the canyon area, and Mary Mountain is no longer gone, and cougar is denning on the west side, north of the road from Madison to West Yellowstone. That's a quick rundown. And what's interesting is if you look at the big picture, sometimes we lose the forest through the trees. There's a period, look at all these territory maps. This is 6 different years. Look at these early years. You can see how they vary every year, how they overlap quite a bit. This is wolves figuring out the landscape. Now here, these later years, the landscape is occupied, and wolf territories are much more stable socially. They figured out how to divide things up. They still have conflict. There's always conflict when you're territorial. Remember, wolves are territorial. The talk earlier this morning, bears are not. They live on home ranges. Home ranges are areas of broadly overlapping use. Territories are areas of exclusive use. Now, that doesn't mean they don't overlap. They do overlap, but in general, the different packs don't tolerate it. And everybody in the world cheats. We all know that. If you can cheat and get away without getting caught, you do it. You trespass and the other pack's not around, you do it, because it might benefit you. But in general, they don't tolerate it. But it all comes down if you get caught or not. And if you get caught, you get chased off, you get injured, or you get killed. It's the way life works. Like this. Like this. This is at the Heritage Center, but those are tooth marks into the palate of the wolf. That is a very effective grip when they're in a fight, is to grab the other wolf's nose and hold on to it and not let go. We have footage of a fight where one wolf got a hold of the other wolf's nose and then would not let go. Oftentimes they jostle for position and the place where they're biting is changing frequently. Not this time. That wolf got a hold of that wolf's nose and did not let go, and he won. It was a fight for 2 males for leadership in a pack. And this is yet another wolf, separate from what was filmed, and you can see the tooth marks there. So this could be a very important, well, it is an important way for the way wolves deal with each other. And one way we understand how wolves deal with each other is uniquely, and many of you help with this. It's a great citizen science, volunteer community, wolf watchers in Yellowstone. We know most of the wolves on the northern range of Yellowstone, not the entire park, whether they're marked or not. And so when a situation like this comes up, this is the old Agate pack, we can identify every wolf in the interaction. So when there's an interaction, we know what they do. And we can sort out how wolves split up duties within the pack and how they defend territory. And so what we found, and this work has been led by Kira Quimby, another graduate student, is that who's ever got the bigger pack tends to win more in battles. That seems to be an obvious outcome, but it's very, very steep slope. So the addition of one wolf makes a huge difference. Huge difference. Other slopes, I'll show you another slope, which isn't quite so steep. So the addition of one more of that thing doesn't mean as much. But the addition of one wolf means a lot in wolf-wolf warfare. You would not want to be these 2 wolves. This is the blacktail pack, 693, 778, being pursued by the old Agate pack. That's a lot of what makes wolf back and forth work. They do this kind of thing. And they've done it for eons. That's how they sort life out. We sort life out like that. That's our history too. And many people have made arguments about the natural aggressiveness of people. And it's been contested and debated, and I'm not really an expert on that, but wolves do it. They probably do it a little bit more here in Yellowstone because we're at higher density. So in the Arctic, when you're at low density, you rarely encounter a neighbor. And when you do, you usually smell them or hear them before you actually see them. So some of this stuff in Yellowstone may be unique because our wolves are packed into a smaller space and there's more wolves there. So that is a very unique feature of Yellowstone. So when pack size is equal, who's going to win? And what we have found is that pack composition is also important, and big males have a huge effect when pack sizes are similar. So you just notice that's the slope I'm talking about. Adding one male isn't quite as important as adding one more pack member, but it does give you an edge. So big males are important in wolf-wolf pack conflicts. They serve a role. They're larger than females, about 20% at full size. And that appears partly to be due to the fact that they are involved in territorial defense a little bit more than females, but females also defend territory. They all do. But these big males, we have now shown quantitatively, are key. I always lose time on this, but it's kind of important, and you're fidgeting a little bit, so that means I'm showing too many data slides. But I'll try and get through these quickly. These are tough data to produce, and we're trying to look at what causes differences in the number of pups born to a particular pack or female. And what you can see here is age. Kind of middle-aged wolves do a little bit better than young wolves and older wolves. This is pups born. Weight is hugely important. Bigger females produce more pups. Medium-sized packs have more pups born. This suggests that there might be stress for resources for the female producing the pups at bigger pack sizes. And then density is a negative effect. The more wolves there are in the landscape, probably the more wolves are competing with each other for access to food. And this causes pups born to go down. Please note this, because the next slide looks at pups survived, not born. That's the difference. And it's slightly different between the two projections. So now, survived, it really drops off pretty steeply for older females. So old mamas aren't quite as good in terms of having their pups survive. Size, again, is a beneficial effect. So for size for born and survived is important. But look at this. There's no drop-off for big packs like there was for medium-sized packs in the previous slide. The more wolves you have, the more pups you have that survive. So even though larger packs produce slightly fewer pups, if you produce them, they'll probably live. So that's a very interesting result. And that probably deals too with wolf-wolf competition. And we're still looking at that, but packs competing with each other for turf, that competition may translate itself into pup survival. We've had other packs go to dens, rip pups out of the den, and kill them. So that could be what's affecting some of this. And then, of course, density, again, is a negative effect. More wolves cause fewer pups to survive. Very difficult to work through. You know, at a starting point, you need 15 years of data before you can even start to look at these kind of questions. So when I talked about at the beginning we had a rare opportunity, it was hard to pull back from some of these studies because of the richness of the data that we're getting out of it. I mean, I know I'll get some phone calls after this talk. Great talk, how long are you going to keep doing this stuff? I do every year. And this is one reason why we keep doing it, because it's a remarkable data set. It adds value to our understanding, not just of wolves, but to nature and management. Very quickly, I present this every year. Some of you have seen it already, and due to the paucity of new hands coming up, I'm not going to spend a lot of time on it. But in Yellowstone, pack structure is fairly unique. Everywhere outside of Yellowstone, the primary cause of death for wolves is humans killing you. In fact, we've looked at it quantitatively 2 different times. If you're a wolf outside of Yellowstone, there's about a 78% probability that you're going to die at the hands of a human being. That makes packs outside of the park very different. I didn't put the graphic in to show you that, but one thing is, most packs outside of Yellowstone are smaller than packs within. And wolf packs in Yellowstone have a great deal of social complexity. What does that mean? They have pups, they have yearlings, they have 2-year-olds, they have 3-year-olds, some cases 4-year-olds, in addition to the breeding pair, and they have a good mix of both sexes. So this is what a simple pack looks like. this is what a complex pack looks like. How they do business is entirely different to how they do business. You've heard me say this before. This is a full-grown wolf, 20% a male wolf, 20% bigger than a full-grown female wolf. Most wolves don't get to full size. Why? Because it takes 4 to 5 years. See the asymptote here? These are drawn in to show you where the graph stops increasing. You can see the difference between females and males. Most wolves outside of protected areas die somewhere in this age range. So they're not even attaining maximum size. So some of the results that I'm showing you have not been discovered before because wolves are not achieving these big size differences that they do when they become full grown. And by the way, the average age of death of a wolf in Yellowstone is about 5. And the data outside the park are less clear. This is based on asking people's opinion. What's the average age of death for wolves in your area? And very few give 5. And so what they do when they hunt is they have a division of labor. You've heard me say this before. These small, sleek wolves, which is going to be a young female, or even an adult female, there's not one here, or a young male, are better at pursuing elk. Here's a little bit of strategy. They've picked out an elk. You've got some wolves here, and you've got this wolf coming at it from a different angle. That's an 8-year-old male approaching this differently. And so there's a little bit of strategy involved. They divide things up. And then here's the takedown, and we have found that large males in a takedown and kill are more important than a smaller male or a small female. So size not only affects territory, size affects killing ability. And so that's probably why male wolves are about 20% larger than female wolves. And notice throughout, we've been identifying each wolf. And so like the territorial battles, and what's very unique to Yellowstone, and again, all of you have contributed in this, is we can identify individual wolves. And that's very, very unique about studying wolves here in Yellowstone. Here's another hunt that was unsuccessful, and 6 adult females chased this elk for about 1.7 miles, and the 2 large males in the pack sat this out. And the females did their job. They have a little bit of strategy going on here too. And the large males weren't anywhere to be around. In fact, the females had this elk cornered on a cliff, a very vulnerable situation, and they turned and walked away once the bull outfaced them. So they felt they had done their job, where are the large males to help them. And I think if a large male had been there, they would have pressed this issue with the elk. The elk would have started running again, then the females would have contributed and they would have brought that elk down. That did not happen. And so what we're trying to impress here is there's a division of labor based on sex and age. And there's a lot of exceptions. Okay? This is not a black and white species. This is not a black and white situation. Nothing in nature is. But these are general patterns that we've observed. This female elk survived the attack from that wolf. So I think there's hardly anything that's tougher than a cantankerous female elk. And when cornered, they can really present a fight. So what do wolves mostly eat in Yellowstone? This is early winter, late winter, spring, summer. These are the 4 periods of time that we intensively monitor them. Here's the breakdown. It's primarily an elk system, but you can see it gets away from that in the spring and summer, especially for deer. And we're noticing more and more bison. Last summer, and data from last summer aren't in this slide, we noticed a lot more bison calves. And so wolves are probably adapting to a different shift in availability of elk versus